Welcome everyone to another edition of Willow's Weather Briefing. Today is Monday, May 19th, 2025. Today we have significant severe weather expected and flash flooding today across the central to southern plains and into the Ozarks and Midwest. We also have above average temperatures continuing in southern Texas and Florida, and also along the Gulf Coast, expected to deplete by midweek. Also, we have a critical fire weather risk in portions of southern New Mexico and far western Texas. And we also expect more severe weather upcoming tomorrow and possibly on Wednesday. Right now on satellite, you can see this low-level cyclone churning up here. Yesterday, it caused a pretty significant severe weather episode across portions of the central to southern plains into the high plains up here in Colorado. And today it is going to be the impetus for the severe weather episode. Today you can already see some thunderstorms forming off this low pressure system here down in around the Missouri River region into the Central Plains and up here in Nebraska. So here was our severe weather reports for yesterday. Pretty good coverage within the moderate risk region. And these tornadoes were not weak. They were pretty strong tornadoes, especially those that formed later in the night in south central Kansas. Very, very large, possibly violent tornadoes over here. And also some strong tornadoes closer to the surface low over here in the high plains. And also a strong tornado over here in western Oklahoma. Overall, decent forecast. Spatial coverage could have been a little bit larger, but I believe this still verifies as a moderate risk. So again, hats off to the SBC. They really know what they're doing over there. Here is the drought monitor. The greatest risk regions are demarcated by these solid lines, and please pause the video if you want to take a look at that. Here we are with our current watches and warnings. A big red flag warning here in the desert southwest into portions of the southern high plains. We also have a fire weather risk in the northern California Valley. It also freeze and frost advisories over here in portions of the west due to much below average temperatures over here. High wind warning associated with that low-level cyclone over here in the northern plains, and also a flash flood watch or flood watch here in the Ozarks region. Again, we also have a frost advisory for portions of the northeast due to that low pressure system spinning over here, bringing in some cold air from Canada. Here is our excessive rainfall outlooks. Today, broad slight risk over portions of the Midwest down towards the Ozarks. We also have a moderate risk here in the Ozarks associated with some training convection expected, and also large rain rates over here. Day 2, slight risk over portions of the Mid-South, Midwest, and up towards the Great Lakes region. This is going to be associated with widespread amounts over 1 inch tomorrow. I forgot to mention today, rainfall amounts could exceed 2 to 3 inches in a pretty short period of time over here in the moderate risk region. Day 3, marginal risk of excessive rainfall over here in the Delmarva region up towards New England. And day 4, marginal risk here for portions of New England. Day 5, no flooding is expected. Here is our National Weather Service heat risk today. Still, heat is continuing in areas such as Texas and building into much of the Gulf Coast and into Florida. But we do expect a depletion of the heat as the week goes on towards midweek, and then that will slowly deplete off the Gulf. And then we will see a building of heat towards midweek in portions of California and the Southwest. And by next weekend, heat will continue over here into southern Texas, though I believe we expect heat to be a little bit less potent early next week than it was this week. Just take some temperatures here. San Antonio, we still have above 100-degree temperatures expected in San Antonio, but this will deplete later due to lows getting almost to room temperature and highs being below 100 degrees. Next weekend, we do expect highs to reach back up there and lows to be a little bit increased, but again, I don't really expect this to be a prolonged heat outbreak like it was before. Over here in the more uh, deserted regions closer to the Mexico border, highs well above 100, lows well almost reaching 80 degrees, so definitely heat risk more so over here in the desert regions closer to the Mexico border. And also areas like Houston could see high heats up to the mid to high 90s over here, but generally generally less so than areas such as San Antonio and to the southwest. He continues to build over here in the Gulf, well above average temperatures all over these regions here. And in places like Florida, could see record temperatures here in cities like Orlando, temperatures reaching well into the high 90s here, which is above average for this time of year in a place like Florida. We are moving on later. We do see the Southwest start to build in heat. Cities like LA could see temperatures in the high 80s to high 60s, which is above average for this time of year. And also in desert regions in Southern California could also see above average temperatures. Here's our fire weather outlook. Critical fire weather risk for areas of southern New Mexico and western Texas, associated with that with some additional high winds and dry weather. There's no fire weather outlook for day 2 or the extended range. And here is our big weather story of today. We have a moderate risk of severe weather throughout eastern Oklahoma into areas such as Joplin and up towards central Missouri. This includes cities like Oklahoma City, Tulsa, Springfield, Norman, and Broken Arrow. By the way, there's about 20 cities in the U.S. named Springfield. This is Springfield, Missouri, just to clarify. And a broader enhanced risk surrounds the moderate risk, including cities like Dallas, Fort Worth, Kansas City, Arlington, Texas, and Wichita, Kansas. Primary risk for this is going to be pretty much all hazards are on the table for portions of the severe weather risk. We have a 15 hatched tornado encompassing the moderate risk. And also we have a 45 hatched wind risk associated with possibly more upscale growth, basically surrounding the Joplin region. And we also have a 45 hatched hail risk for much of the moderate region. Here we go, day 2, enhanced risk over portions of the southeastern United States. The main risk will be tornadoes here. A broad 10 hatched region over areas such as Memphis and Nashville, Tennessee, Huntsville, Alabama, Clarksville, Tennessee, and Murfreesboro, Tennessee. Wind risk unhatched 30%, and hail risk 15%, associated with more moist low levels and upper levels. And generally, the hail risk is expected to be a little bit less than previous days for sure. Day 3 outlook, marginal risk over the eastern seaboard. Currently unsure of the hazards, but this is definitely supposed to be less of a severe risk than we've seen before. And the extended range predictability is too low. Now, going into the model guidance, we're actually going to start with the HREF ensembles here and just take a look at our storm coverage. 12Z is actually just coming out, so let's look at 0Z here. So going into today, we have ongoing storms across these areas, which we saw today, and still storms initiate earlier in the risk kind of time frame, which we saw on the satellite. So this is about 16Z, about 11 a.m. So storm coverage early on, probably not progged by this particular model well enough, which will of course have implications for severe weather later by depleting some of that environment. And as we move on, storm coverage is expected to increase pretty early on into the day, around 19 to 20 Z. That might be owing to the strong synoptic support throughout the day, lifting that elevated mixed layer that is consistently advecting into this area. So storm coverage is supposed to be much higher today than it was yesterday, which will, of course, modulate our hazards and associated severe weather risks. This upscale growth is probably the reason why they have a 45 hatch for wind in some of these areas. So this will most likely congeal into a mesoscale convective system as it moves on later into the night, probably sooner than later, to be frank, and moves on towards the east, bringing severe weather downstream of any organized complexes of severe weather. But early on, depending on the way that the storms cooperate along the boundary, you could see some discrete and semi-discrete modes earlier on into the risk regime, starting honestly as early as 2 p.m. We could see initiation along this dry line, possibly even earlier than that. Let's go ahead and look at our updraft helicity. Let's do paintball updraft helicity here. Over here, we could see, again, large swaths of updraft helicity. This is basically the spin that the mid-levels will have, basically a proxy for supercells. And you can see broad signals of supercells, especially in areas such as eastern Oklahoma, southeastern Kansas, and western Missouri. Again, fairly early on, too, we could see initiation as early as 1 to 2 p.m. in these regions. Of course, that will continue to bring upscale growth, possibly embedded supercell clusters in regions downstream of the risk area. All right, so let's take a look at our other model runs here. Let's start with a broad look at the 500 millibar height and wind. You can see our upper level trough over here, broad upper level trough, and we see this region right here associated with our severe weather yesterday, and that is going to sort of continue to eject to the north over here as we move forward in time. This trough will slowly make its way north, and then this digging will cause our severe weather for today down here. So, in general, this will cause our forcing for today. This trough is going to be a severe weather maker, and as we move on, that trough will translate to the east and bring severe weather tomorrow into regions such as the southeast. So since this is more so a flattening trough, of course, that will modulate our potential hazards and any regimes of more localized forcings. As you move forward, an upper level ridge begins to build in the west, bringing us above average temperatures for much of the southwest and much below average temperatures for portions underneath this upper level trough. This ridge is progged, at least on the GFS, to continue to build in the central US, kind of blocking any troughs that may impinge on the central United States. So we are expecting a quieter pattern coming into late this week into early next week. Let's go ahead and look at our surface responses here. Here's the GFS. We have a low-level cyclone sort of meandering across the central United States, and then we'll reinvigorate as we get that ejection of the full upper-level trough and then much broader area of convective coverage here across the risk area. That low-level cyclone will continue to move east, causing our severe weather risk tomorrow as we get more moisture return from the Gulf and additional severe weather over here in these regions. Surface cyclone will continue to move off to the east, and then mainly high pressure will dominate over the central United States as we get that ridge building in. All right, so let's go ahead and focus in on our corridors of most concern today. This is the ARRR model. As you can see here, the low continues to meander, possibly strengthen a little bit as we get that troughing to really impinge on the area. And the convective coverage is expected to be pretty high today. Again, 18Z on the ARRR is where we see that convective initiation. So as early as noon to 1 p.m. really is where we're looking at initiation. So things will start to ramp up and start to grow upscale, possibly multiple rounds, at least progged on the ARRR over here based on the simulated reflectivity. Take a look at our boundaries here. This is theta E, a proxy for moisture. You can see that the first round of initiation may be associated with this lifting warm front up here, possibly some prefrontal bands of confluence, which can act as a mesoscale forcing. So we see those storms kind of forming off this particular boundary here. And we also have the dry line set up in this region, and possibly a secondary boundary setting up right here. Take a look at our temperatures regions. So yeah, we have like almost a secondary, it looks like almost a secondary warm front here setting up on the ARRR. Basically, considering that we have as high moisture values in western Oklahoma, but just higher temperatures, this does look like almost a secondary warm front that may serve as a focus for initiation, at least early on into our risk period. And over here, as we get to 0Z, this is now going to be our dry line. It's going to be a focus for our initiation. So let's go ahead and look at our instability values. Let's go ahead and look at mixed layer CAPE. Over here, plenty of CAPE to work with, even in the mixed layer. Over here, close to initiation around noon to 1 p.m. You can see values elevated 3,000 to 4,000 joules per kilogram, so plenty enough for initiation. And even continuing to build across the day in those areas west of that secondary warm front, across that dry line, possibly multiple rounds of convection there. Take a look at our bulk shear values, 0 to 6 kilometer. Expecting high bulk shear values early on, possibly not that much as that jet isn't really impinging much of the regions just yet. But the thing is, if we get this earlier round of convection, it will deplete the environment for those storms that form off the dry line and do end up taking advantage of this larger bulk shear environment. So that is possibly a fail mode for today. Looking at our low-level storm relative helicity here, you can see generally high storm relative helicity to start off the period with, but it will deplete as we get daytime heating, and then will reinvigorate towards the evening hours, especially in regions west of that already initiated convection off that secondary warm front. And then that will, of course, these storms off the dry line will, of course, take advantage of the shade environment. And when these storms grow upscale, the sufficient low-level shear will be enough to organize and maintain a mesoscale convective system for quite a while, I'd imagine, throughout the night. Because again, I've said this before, the reason why we have this enhancement of storm relative helicity at night is because of the low-level jet, and that sort of acts to continuously feed moisture and balance to a mesoscale convective system. So let's go ahead and take some soundings. Let's use reflectivity just to make sure that we're not going to sully any environment here. Let's take one here at the northern regime towards Kansas. And Pretty interesting environment here. Pretty saturated in the lower levels, but your LCLs and LFCs are pretty high. But forcing is going to be strong if we get that secondary warm front. So most likely, forcing will probably not be a concern. These limited low-level instability and relatively straight photographs are more keen for a hazard like hail, but sufficient low-level curvature in the photograph and decent low-level instability should be sufficient for a hazard like tornadoes. Take a look further down south in eastern Oklahoma. Less storm relative velocity to work with. Again, this is 2 p.m. before any low-level jet response. Much more elongated photographs, which could be better for a hazard like hail, and also less storm relative velocity at the surface may be more conducive for a hazard like hail. But we have higher low-level instability, lower LFCs and LCLs. So upscale growth, given the forcing, could be an issue early on, since these LFCs and LCLs are so low, and there really is no capping to be seen at this early on, possibly because of the amount of synoptic forcing we've been getting for, I don't know, the past while. We've been getting continuous synoptic support, so an EML is pretty hard to build when you have that type of regime or that type of precedent conditions. Finally, let's take a look at the southern regime closer to Texarkana, northeastern Texas here. Better instability, probably down here by the HRRR. Low level instability, a little bit less due to higher temperature dew point spreads, but your LFC and LCL is still pretty low. A little bit wonky in the mid levels in the photograph, but still well elongated, good enough for significant hail and tornadoes. Moving on, let's take some soundings with the secondary batch of convection here in Kansas and Oklahoma associated with that dry line. Now, the environment will be modified by any preceding convection, so take these environmental soundings with a grain of salt, but nonetheless, let's take a sounding over here in northeastern Kansas. As you can see, pretty wonky thermodynamic profile. I assume the thermodynamic environment, is modeled to be heavily modified. As you can see, lower temperatures at the surface, more stable upper levels, warmer upper levels, thanks to the preceding convection. And even your photograph is a bit wonky here, so a bit messy of an environment here for that dryline convection. Let's take a look at some place in eastern Oklahoma. Let's try to take a better one than that. That's probably as good as we're gonna get. Pretty dry mid levels, but overall LFCs and LCLs are right on top of each other, pretty low. So, and this environment looks to be a little less solid by our preceding convection. Our temperatures at the surface are a little bit cooler, but we still have sufficient low-level helicity for a hazard like tornadoes, sufficient shear for supercells, and also a lot of low-level cape to still work with, initiating those storms along the dry line and helping our tornado potential just a little bit. So definitely need to watch out for areas in central to eastern Oklahoma along that dry line. Further down in Texas, we have even higher temperatures, more curved and straight photographs, but this is overall a pretty good environment, possibly because the southern environment is less sullied by that preceding convection, at least modeled by the HRRR, but still large amounts of instability values, long photographs, and curvature at the low levels sufficient for pretty much all hazards here. So I think moral of the story is that preceding convection will try to modify the environment a little bit, and depending on how that goes, it will possibly make or break our main show here along the dry line. So first round of convection, possibly initiating around 1 o'clock today, possibly noon to 1 o'clock, and then our dryline convection will initiate around a more classic, per se, period of initiation, possibly around 4 to 5 p.m. So that's not the only model we got. Let's just take a look at the NAM. I haven't really liked the NAM lately, but NAM shows little to no convection across here. Let's take a look and see if it has that frontal regime. It does not. So that's kind of the main reason why it's kind of iffy over here. I think we still have a semblance of that pseudo warm front here in at least a baroclinic zone to add forcing here in the open warm sector. Down here in Texas, it's less so on the it's more so widespread on the ARRR. So that's probably why we see that initial convection forming a bit south and not so much up here with the NAM. But what both have in common is that dry line initiation here. I believe the NAM could possibly be more conducive for severe weather since we do not have that preceding convection along that warm front sullying the environment before we reach peak diurnal heating, but who knows? We would need to watch observations pretty closely around here. So over here, still a discrete storm development, at least over here in Oklahoma, but northern modes like Kansas grow upscale pretty quick on the NAM, probably because there's more forcing along that low pressure system. The low pressure system kind of looks a bit wonked out on the NAM a bit, possibly because of convective feedback. Even a low pressure system forming on that MCS here in eastern Kansas. So let's go ahead and take some soundings on the NAM. Pretty good environment here, at least thermodynamically. We have low LFCs, LCLs, which will help possibly with that upscale growth, and a lot of instability here in the upper levels, pretty low temperature dew point spreads at the surface, large low instability, and sufficient curvature at the low levels for tornadoes. And also, of course, elongated photographs for hail as well. Let's go ahead and take a sounding down near Oklahoma at around 7 p.m. So let's take an environment that's a little less sullied by the convection, and as you can see, there's an elevated mixed layer here on the NAM, but still very potent instability here in the upper levels. Pretty wonky photographs, pretty straight photographs. So this is a pretty conducive sounding to hail, but the only thing that really mitigates that is the amount of low-level instability before your hail growth zone. If you have a lot of low-level instability below your hail growth zone, it sort of just shoots the hail nuclei up above the hail growth zone, and you won't get that nice balance you need to just keep hail aloft into that growth zone. But due to the amount of instability we have aloft, of course, we have a significant hail analog here. It certainly is possible that we get big hail, but to me, this is just a little less conducive for a large hail development. But still, the potential is definitely there. So it is going to be difficult to take a sounding really too far downstream because the environment down here is heavily modified. But trust me when I say that when the low-level jet kicks in, storm relative velocity kicks in, it will continue to pump up moisture and feed the balance of this MCS, which will probably end up being fairly prolific as it grows upscale. So of course, another thing that we look at is our bulk shear vector orientation with our initiating boundary, which will give us a decent idea on storm mode. So over here we have a dry line. Let's move forward to when we actually have dry line initiation. Generally same orientation though. So we have a dry line across this region right there. And let's take a look at our, carefully look at our bulk shear vectors here. In these areas, let's go forward. And generally fairly parallel to the initiating boundary, so could have some concerns there as we get storms to initiate. Shear vectors seem a little bit more conducive at some portions, so we may see some initially discrete supercells or perhaps some supercell clustering over here. But since the forcing is a bit larger along that warm front, we could see, or along that warm front progged by the ARRR, we could see further upscale growth there. Since the forcing is larger, but our shear vectors are a little bit more perpendicular in these regimes, but we have larger forcing. So kind of a trade-off there in terms of storm mode. But our dry line initiation kind of 45 degrees to the dry line, which is pretty good when you want sort of a discrete dry line storms. But again, the uncapped nature of the thermodynamic environment brings still, despite being pretty good shear vectors, still brings slight concern to the storm mode that we'll get. So a bunch of trade-offs, but most likely what will happen is the clustering of supercell storms, perhaps one or two discrete supercells out there that can maintain discrete throughout these more subtler forcing regimes, especially along this dry line. So let's go ahead and take a look at the GFS for our future risk here in the southeast. You can see here that low-level cyclone will continue to move east and pump up moisture, priming our environment for tomorrow. I'm actually more keen to look at a convective underlying model here. Let's go ahead and take a look at our HRRR. We're here on Tuesday. We have a boundary set up along the Mississippi River Valley at around 2 p.m. So a lot of moisture, definitely kind of looks like a dry line, at least here in the mid-Mississippi River Valley. Might be a dry line slash a Pacific front. The difference between a dry line and Pacific front is that a dry line has warmer temperatures on the dry side, and Pacific front has about the same or maybe a tad lower temperatures on the dry side, which will change your magnitude of forcing. So if we have this more dryline feature, then maybe forcings will be sufficient to maintain a more discrete mode over here. Take a look at some soundings, and wow, that's actually a pretty good sounding. Classic Dixie, skinnier cape on the upper levels, low LFCs, low LCLs, pretty small temperature dew point contrasts in the low levels, and pretty good curvature in the low levels on the hodograph. Let's look at up here towards the Tennessee area. Make sure that we don't get contaminated again. We do have some semblance of some preceding convection tomorrow, which may sully the environment up towards the north. But again, let's try to take one in west central Tennessee. And again, cooler temperatures, but still sufficiently high moisture, really making your LFCs and LCLs very, very low, below 500 meters. And sufficient low-level curvature will easily bring some possibility of tornadoes to this area. Finally, let's go ahead and just take one a bit further north here. And this all just seems initiating pretty darn early, maybe around noon to 1 p.m. And up here, less instability aloft, primarily because of the lesser dew points down here and possibly some cold air aloft not making it. But curved photographs will be sufficient for a not curved, long photographs will be sufficient for a hazard like hail, but less upper level instability could mitigate that hail threat. So supercells threat, pretty large area, but our primary tornado threat is for sure going to be down here, associated with that higher low level instability. Generally, I won't go into much detail about the eastern seaboard, but generally this all will continue off to the east, bringing a marginal risk of severe weather over in these regions. Here's our 6 to 10 day temperature outlook, valid May 24th to 28th, much below average for the eastern United States and above average for the western United States and portions of the southern U.S., such as Florida and Texas. 6 to 10 day precipitation outlook here. We have much above average for most of the United States, with exceptions such as the Southwest and the Upper Great Lakes region. So So that is going to be it for today. Of course, if you enjoyed this video and you have any constructive criticisms, please leave a like, subscribe, and leave a comment down below. If you want to know more about your specific area, please refer to your local broadcast or National Weather Service meteorologists. Thank you and have a great day.